Good day. My name is Kealey Ruhaya, and I'll be taking you through my medical image classifier project. The purpose of this project is to aid medical practitioners in diagnosing tuberculosis, a disease that affects millions globally each year. With early and accurate detection, medical professionals can make informed decisions, initiate treatment sooner, and ultimately save lives. South Africa is one of the 30 high burden countries for tuberculosis, and diagnosing this disease from chest x rays remains a major challenge. The complexity arises from various symptoms seen on x rays, which can be difficult for even experienced radiologists to interpret. The quality of the images and the subtlety of early stage TB symptoms make this process very complicated. In this context, the AI system can offer a solution, but the question is how can it help in making this process easier and more efficient? So my proposed solution is to make a project that addresses this problem by leveraging AI, particularly CNNs, convolutional neural networks, to automate TB detection. So the goal is to train a model to detect TB using chest X-rays and using a chest X-ray dataset. So the dataset that I chose to use for this project is the TBX11K dataset. Is a large collection of chest X-ray images specifically focused on TB detection. TBX11K is a compilation of other datasets like chest X-ray 14 and the National Library of Medicine's tuberculosis dataset, which makes it a robust resource for training the model. So in this dataset, I've split it into three categories. There's healthy lungs. So it is a chest X-ray of a healthy lung. There is another category that is sick, which is sick lungs but not TB, and then TB positive case. So in the first pipeline, this pipeline I did not use any external libraries. So in this pipeline, we're using CNNs, and we load the data set into the data loading class, which is called the data loader class. And this class reads the images and associates them with the correct labels, which are stored in a text file. Once the images are read and labeled, they are prepared in a format suitable for pre-processing and training the model. This process ensures that the system has clean, well-organized data to work with. So for the data processing, the three functions that I chose to pre-process the data, which is resizing, grayscale conversion, and normalization. So onto the actual CNN architecture. The whole model's structure is 4 layers. The first 2 layers are convolutional layers. So the data would flow through the first layer onto the second layer, and then onto this two last layers, which are fully connected layers. And this first fully connected layer will take the output from the previous layers, the convolutional layer 2, and then flow through them accordingly and end off in the fully connected layer. So the activation functions that I chose to use are the ReLU function, softmax, and then for the loss functions, I used cross entropy loss. So for the training process, during this phase, the input data is passed through the CNN layer by layer. So the convolutional layers are where the model extracts essential features from the images, such as edges, textures. This is critical for understanding the visual information present in the chest X-rays. Next, the model moves into the fully connected layers, where it combines the extracted features to make a final prediction about the class, whether the image is classified as healthy, sick, or TB. At this stage, the model outputs probabilities for each class, indicating how likely it is for an image to belong to each category. Then the loss calculation is calculated. So for model persistence, it saves the trained model in a NumPy array, and it can be loaded for later use. So I'm going to go through a visual demo of the first pipeline. As you can see, this is the first pipeline. We can upload an image of a chest X-ray. We can choose a healthy lung and classify the image. So right now, it is trying to classify the image. With this pipeline, the classification takes a little bit longer because of the way that we save the model. Because there is no use of external libraries, which would make the whole process of classifying a lot faster, as I will show in the visual demo after in the second pipeline. As you can see, it has made a prediction. Now I will go through my second pipeline. So for this second pipeline, we used visual transformers and we used external libraries. So for this pipeline, the accuracy is a little bit better and the speed and performance of the entire pipeline is better because we were allowed to use external pipelines. So for the data set and the data loading, it is the same process as the first pipeline, as well as the pre-processing to keep everything a standard format. So onto the visual transformer architecture. Um, so for this architecture, I utilized the VIT for image classification model from Hugging Face's Transformers library. The Vision Transformer operates on an architecture originally designed for natural learning processing tasks, but adapted here for images. The key components are patch embedding, positional encoding, transformer encoding, and then lastly, classification head. So the training process for the vision transformer, we first begin by splitting our data set into two parts, training set and validation set. Next, we define loss functions and optimizers. The training process runs across multiple epochs. Each epoch represents one complete cycle through the training data. With each epoch, the model iteratively improves its predictions. To ensure the model is learning correctly, we monitor performance metrics during the training, such as accuracy and loss. In our case, we use the trainer class from Hugging Face's Transformer library, which simplifies the entire training process. So for saving the model is the same as the first pipeline. And now I will take you through a visual demo of my second pipeline. Here is my second pipeline using the visual transformer. As you will see, we'll go through the same process. We'll pick an image of a healthy lung, and then we'll click on classify image. As you can see, this is more accurate and it was a lot faster to classify the image. Thank you.